Mass and Energy Balance or Biosystem. Module 5 Conservation of Mass. Segment 2 Review of Mass Accounting and Conservation Statements. Ismi Lili from School of Life Sciences and Technology, Institute Teknologi Bandung. In the previous segment, we already discussed about the basic mass concept. And now, in this segment, we will discuss about the review of mass accounting and conservation statement. Mass accounting equations mathematically describe the movement, generation, consumption, and accumulation of mass in a system of interest, and it can be used to analyze any mass descriptor such as total mass, total moles, and spatial moles. And also, mass can be generated or consumed by chemical reaction in the system. And mass may also accumulate in the system. As we can see in this figure, we can see that mass entering and leaving the system, and it's represented by M in and M out. And also, mass can also be generated or consumed by chemical reaction, and it also can be accumulated in the system. Algebraic equation can be applied when discrete quantities or chunks of mass are specified, and the generic algebraic accounting equation can be written as psi in minus psi out plus psi generation minus psi consumption is equal to the psi accumulation. And as we learned in the previous module, the psi accumulation can be defined by the psi final minus psi zero. And also, for the extensive property psi, it can be replaced to solve for system involving mass, species mass, element mass, moles, mole of species, and also moles of an element. And for a differential form of the accounting statement is more appropriate when rates are specified, and it can be written as psi dot in minus psi dot out plus psi dot generation minus psi dot consumption is equal to the psi dot accumulation. And for the psi dot in and psi dot out terms are material flow rates entering and leaving the system and also across the system boundary. And the another form, the integral accounting equation is most useful when we try to evaluate condition between two discrete time points. And as we learned in the previous module, the integral form can be written as shown in this slide. And now for the conservation statement. The conservation of mass equation mathematically describe phenomena where mass is neither created nor destroyed. And the conservation, it can be universally applied only when counting total mass, element mass, and also element moles. For the generic algebraic mass conservation, it can be written as psi in minus psi out is equal to the psi accumulation. And for the conservation equation is written in differential form, is described as psi dot in minus psi dot out is equal to the psi dot accumulation. And for the integral form, it can be written as integral from t0 to tf psi dot in dt minus integral from t0 to tf psi dot out dt. It's equal to the integral from t0 to tf psi dot accumulation dt. And for an accounting statement, it can always be used for all representation of mass and moles. A conservation equation can always be used for a non-reacting system, but only for certain representation of mass and moles for reacting system. And in this table, it shows the appropriate usage of conservation equation for reacting system. And for total mass, it's valid for using in the conservation equation, but no for species mass and total moles and also spatial moles. In the next segment, we will discuss about the open non-reacting steady-state system. Until then, I'm Lily from Institut Teknologi Bandung.